Okay, hello everyone. Welcome to Communication 201W online version. Very interesting times as usual. Thanks to Jarrett for sending this link to the cartoon that we have here. I won't talk too much about what's happening because I think you're all flooded and inundated with that kind of stuff, and it's pretty intense, so all good. We do need to talk about a couple things though, like flattening the curve. Interesting link to an article here from the New York Times and looking at how South Korea flattened the curve and how important it is. All these measures that we're taking, super important. And also in terms of this course, what you're looking at here is a frequency distribution, number of cases, and on the y-axis and on the x-axis time since first case. And it's pretty clear what this all means and what we're doing. But in particular in this course, I think we are in a position to have a certain kind of understanding about this just based on looking at a curve and having a sense of what that means. So enough about that though, because like I said, I think you've all been dealing with it quite enough. And our goal right now is just to get everyone nicely through this course. And we've set up a lot of stuff for you. And we feel pretty good about how we've been able to do that and the support we're going to offer you and will be offering you as we move through the completion of assignment 3. So back to the good old wheel. It's so comforting. Yeah, sure, it looks like a record, whatever. Just pointing out that as we move along here through this course, we've done the research question, designed the study, collected the data, and now we're moving into the home stretch in this course, which is analyzing the data, interpreting it, and informing others. And as we move along, looking at taking the steps to interpret the data and inform others, which is basically assignment 3. And so when we complete assignment 3, we'll have taken a turn through this wheel fully. And I think that's kind of exciting. The data looks really good from the online survey. Thanks everyone for taking part in that. Super exciting. This is another really important part of what we've been doing. Conceptualization, coming up with ideas about things we want to measure, and then operationalization, developing specific procedures or operations that will allow us to make empirical observations about those concepts. And so all that is certain words to describe the process of coming up with questions on a survey. And now we've done that and we've got the data and we can start to move ahead. Remember, we're going to be looking at variables. Each question in the survey is a variable. And variables, properties of objects that can change, very simple. And we're going to be looking at relationships between independent variables and dependent variables in assignment 3. And we've covered this already. We had some great labs back in the day. I remember being there for some of them. And we did go over bivariate statistics, and we've started this process already in SPSS for you. A correlation, this is just drawn right from the textbook. Empirical evidence that a change in one variable is systematically identified with a change in another. So this is the sense that we're using the term correlation in this class, taken from the textbook, or association. And just to clarify some terms, an attribute is a characteristic of a variable, basically. So a female would be an attribute of the variable gender in this example. And we see that in our survey. Back to this concept here, reasonableness, my favorite word these days in particular. A quality of mind that is open to new ideas and evidence. This is what we all have to do always, but in particular in times of crisis, this will be demanded of all of us. And I'll put this slide in for those reasons, super important. I do want to talk a little bit about control variables today, but I'm also going to be very clear that I've taken out a lot of parts of the course that I thought would be too much for us to tackle in an online format. And what I'm saying very straightforwardly is that I've made things much simpler. And so this is a bit of a challenge for me because I need to kind of, present certain parts of the chapter, but nothing that's going to be too confusing because we, won't have the regular instruction modes, all that kind of stuff. So bear with me as I try to do that and talk about the basic things we need to know about control variables for this assignment. So univariate statistics, bivariate statistics, this is what we're talking about in this class. Univariate, we've been doing a lot of this. We've been doing that in SPSS in the labs and talking about it in the lectures. And so just to be clear about what we're talking about with univariate, as one variable at a time. And that is frequency distributions, measures of central tendency, mean, median, mode. We've covered this stuff quite a bit, so I'm hoping that that's pretty straightforward at this point. And measures of variation, there's lots of them, but we're just focusing on, again, making this very basic, the range and the standard deviation. And moving into bivariate, like we did for the last lab, analyzing tables and crosstabs and things like that. And we're looking for potential relationships between variables. And so bivariate statistics, that's what it's all about. We're looking for relationships. We're trying to put an independent variable into a table and set it up properly and look and see if there's a relationship between the independent variable and the dependent variable. And if there is, then we'll call it a correlation or an association. And in this course, again, as we've mentioned a few times, I'm sure, we'll do this in a certain way. And the way we're doing it is simplified. It is in general, even before this happened. We try to keep things, as I've been saying, and you were there to hear that, keep things nice and simple. But especially now, again, I've taken steps and I've changed assignment 3 to keep it more straightforward even for us. So, having said that, I do want to spend some time looking at bivariate tables and pushing forward in this. And so what I want to do is use an example that I've created. It's a hypothetical example, obviously. We have the independent variable, which has just got more or less of something, and the dependent variable, which is, just down and up. It's very simple. And I've set this up so that there's, to see what it looks like when there's no relationship between variables. Everything's just dead even. And to make it really simple, decided that there's 100 total. Our total count is 100. And the little pink box is there. The point about putting these in is just to kind of start explaining what the count is, right? So you look at the independent variable, we'll start at the bottom, less, and the count is 25. That's just how many of them were there. And they're distributed equally between all the 4 boxes. And the expected count is something we haven't really covered yet, but I do think it is important for setting up the crosstab. And so we'll be talking about that in the labs, how to set up the crosstabs properly. And so we do want to put in the expected count just so we can sort of conceptually start to get this. And that's the point of showing you this stuff. So don't get freaked out about it. It's a tick box in SPSS that you check. But the point about doing these slides is that you get more out of it and that you can actually be able to develop what it takes to look at a table and make sense of it. And we think that's important, obviously. So here's the expected counts. And so the expected counts, again, I've got it on my slide. You don't need to memorize a formula. Won't be on a quiz or an exam, obviously. That's from a previous semester when we actually did have the exam, but we don't anyway. So, whatever. The expected count is, it gets a little fuzzy, or seems a little fuzzy at the beginning, but it is what you would expect in each box, like the number of actual counts. And in this case, because everything's just split in half, the expected count is the same as the actual count. So you just see in this case, the point about setting up this hypothetical example is when there's no relationship, then what we're seeing is no difference between the actual count and the expected count, right? It's 25 for the count and 25 for the expected count. It's just there's nothing happening here. And so that's where you do want to compare the counts just to get a sense of it. But the reason why we use percentages, and we'll talk about this more, is because this is a hypothetical situation, but obviously you're never going to see this. Like if you have 100 of something and you measure it in different ways, it's extremely unlikely that everything breaks down in this very even way. I've never seen it, for example. There's always a difference between the count and the expected count. The question is how much. And the reason why we do the percentages instead of just looking at the counts is because if there's differences between the numbers, then you need to have the percentages to make sense out of it in a relative way. So hopefully as we go through these slides, it'll make a bit more sense. So here's the row percentages. They add up to 100% across the row. And we've been working with that. So remember to click row percentages when you're doing your stuff in SPSS. And this is the most important part of assignment 3 and really the course and everything. This one slide, you can see what we're doing. We're comparing the row percentages up and down within a column. So there's a reference from the text here, and there's a simple rule. If the table is percentage down, read across. We're not doing that. We're doing the second option. If the table is percentaged across, read down. And that just means that we put the independent variable in the row, dependent variable in the column, and we compare up and down once we've set it up that way. Again, just to make it very simple and make sure everyone's on the same page for marking and that kind of thing. So, hey, let's look at some data. This is from previous runnings of the course. N is 712. That means that this is data collected from 712 students in this case. And we're looking at GPA, always a fun variable, something you can work with. It is of interest to many people, as it turns out. And this is univariate statistics we're looking at. This is one variable at a time. And we're checking out GPA, which you will be able to do in the current data set. And typically it breaks down in the same way. Every time pretty close, something like this. But this is me taking data sets from different semesters and packing them together, looking at one variable at a time, which is always your first step. Univariate statistics, checking out the frequencies. There it is visually, just looking at it. Okay. The reason why this is important is because it's nice to be able to look at a graph like this and start to make decisions about how to group or recode the variable, because for our course and our purposes, we want to have very simple attributes, right? 2 categories. We want to have basically low GPA and high GPA. And so Pippa is going to be talking about that and the specific procedures to be used, but I just want to try to reference things from this set of slides as much as possible. Here's another one. This is a very simple variable in a sense because there's only 2 attributes, yes and no. There's a number of variables in this data set like this. And so this is, have you attended private school at any time in your K-12 education? And we have a bar of no and a bar of yes. And if you look at the table, 454 people said no. So that's the frequency. And that's the actual count of people saying no versus people saying yes, which is 252. And just notice the percent column next to it. So this is univariate statistics, one variable at a time. Interesting thing that some people might be curious about, is there a relationship between, let's say, an independent variable, did you attend private school, and GPA? Now, there's always problems with things, and that's fine. We want to point them out. So some of you might be thinking like, what? Well, what if you went to private school for one day and you answer yes? I mean, what about that? And I would just say in cases like that, it's good. Talk about it in your assignment. There's room for that in the conclusion to say, there was a problem with a variable or something like that. And so that's fine. I see that as an issue with this question. And, some of them would do actually keep as ways to talk about things like this. So, I mean, I could probably fix that. Maybe someday I will. here's the crosstab. And this is now, we have independent variable. Have you attended private school at any time in your K-12 kindergarten education, kindergarten to grade 12 education? That's the independent variable. And the GPA, because that's happening now, it happens after K-12. So that should be a pretty good clue about which is which. In this case, I don't think you'd have a good case to switch those. I don't think your current GPA would be affecting your life in the past, really. Without some kind of science fiction component, it's just not going to happen. So new GPA, dependent variable, attending private school, independent variable. Okay, so we look at the counts. The pink box is highlighted in front of you. And notice that the total count is 613. And that's the count from each box added up. So the first one, we'll just start at the top. And so no, people answering no with a lower GPA, 182. And below that, we have 104 people saying yes with a GPA under 3.0. And that's one column. Now we'll move to the next column over. 3.0 plus, 214 people said no, versus 113 people. So again, you can start to compare those numbers and also look at the difference between the count and the expected count and see that there's slight differences in here, right? So we look up at the no row and under 3.0 column, and we'll see that the count we actually got was 182. But by the way the expected count is calculated, and let's not get into that. This does actually explain it, but you don't have to worry about it too much. It'll just calculate it for you. So we'll leave it at that in this semester. Is 184.8. There's a 2.8 difference in there of actual count. So we can, I think, already see that difference is pretty small. The difference between the count and the expected count in each of the boxes. They're all very close. Fine. And then we want to, that's what we just did, comparing the count to the expected count. Boom, boom. That's what I was just talking about, basically. But more importantly for us, comparing the row percentages up and down, one column at a time, right? And this, again, when the independent variable is in the row, this is what you have to do. And just to be clear, so you do it for the assignment, you'll talk about each box and each percentage and compare them. Do one column, compare these guys, and then compare the next ones like that and just give the difference. So here with 54% versus 52.1, simple maths, what's that? I think it's 1.9% difference. What does it mean? Well, that's less than 10%. So for this course, and in the simple way we're doing this, again, very simplified for a number of reasons, 1.9% is less than 10%. So what we're saying is that this is not providing evidence that there's a relationship between the independent and dependent variables. Boom, that's it. So one thing I'll say when I'm using this example, I just want to be clear with you, I use it specifically because it's not good to use in for assignment 3, because we want to be looking at social media or things about the questions that you guys developed and stuff like that. So even though it is interesting to look at this relationship between attending private school and GPA, it's not a good one for this course simply because we're in communication, not education, and you should be looking at communication type things like relationships between using different platforms in GPA, for example. That could work. That could be very interesting. Lots of stuff to work with in the data set. So here we are. Well, sorry, it says recall. Don't worry about that because I've changed these slides around a bit. A directional hypothesis. This is one where you predict a direction of the relationship. So it could be that, if depending on how you feel about it or what your hypothesis was, maybe you thought that if you went to private school, your GPA would be higher. So you're making that prediction. And the private school GPA example doesn't really work very well for the positive correlation or the negative correlation because for that to make sense, we need something else to look at where we can see that if the independent variable goes up or down, then the dependent variable goes up or down, and it makes sense. But the difference between yes and no as attributes of the variable have you attended private school doesn't really work for us here. You can't do a positive or a negative correlation. In that sense, what we'd need, it could be set up that way. Like if we ask the question like, how much of your schooling, and this is probably the way we should set up the question, how many years, for example, did you spend in private school, might be a much better way to ask that question. Then we could look for a positive or negative correlation, because we could say, well, we predict that if you have more private school, or the other way around, more public school, then GPA goes up or down, or something like that. So this is what that would look like: a negative relationship, positive relationship, 0. Don't worry about curvilinear, it's just in there. It's a big frown right now because of what's happening. But ignore it. Just ignore that frown on the right. We're gonna I should have just taken it right out, but I didn't. Anyways, 0 relationship means there's just nothing going on. Again, for us, this means that there's not a 10% difference or greater between the row percentages. That's all we're looking for. And then a negative relationship would be, the classic example that they use, hours spent partying the night before an exam and result on the exam. As the number of hours of partying goes up, the scores on an exam might go down. Dumb example, sorry. On the other hand, a positive relationship could be two things that go up at the same time. So hours of studying the night before the exam, or the week before the exam, most likely, and outcome on the exam, you would hope for a positive relationship there, that they're both going up. So let's look at something like that. Here we have another interesting variable. Throughout the ages 6 to 15, did your parents restrict or control your online interactions? Again, lots you could say about how this question was set up, how we operationalized it. That's us. And it could be improved, I think. But it's a good question to look at. And more importantly, for what I was just talking about, we can see that you can divide it into less and more frequently. So now it's directional. It kind of makes sense. This independent variable here is possible to have a direction in it. And here we have the crosstab. So I'm skipping some steps because I don't want to show them every time. Independent variable, how often did your parents monitor your use of the internet? And broken into just more frequently and less frequently. And then GPA, under 3.0 and then 3.0 plus. Notice that when I created the categories for GPA, it's under 3.0, so that doesn't include 3.0. And then it's 3.0 plus. So just conceptually, that if we're thinking, well, where does 3 go? Exactly 3, it would be coded in 3.0 and plus. So we've got row percentages here. Great, they add up to 100% across the row. We compare the percentages up and down. And here, this is an interesting result, and I like to throw it in just for fun. The row percentages here are greater than 10%. Like, not by much, just sneaks over 10.4. And but for this class, again, and let's be specific. Let's just say 10% or greater, okay? So if it's under 10%, we're going to say it doesn't provide evidence. If it's exactly 10%, which can happen, we'll call that providing evidence. Just as long as you know that that's our rule of thumb and that's our way to train to look at a table. It's not how you would actually make that call, but that's for another course. And doing one column at a time, comparing them. And obviously you'll see there's kind of a cross pattern here, and that the percentages are the higher percentage in the under 3.0 column is on top, and then when you go to the 3.0 plus, it switches around, right? And I hope that kind of just makes sense intuitively. They're the opposite. Doesn't always work out exactly like that, though, for certain mathematical reasons and reasons in terms of selecting cases and things like that we'll get into. Okay, so this is just some stuff that we've been talking about. Percentages versus raw frequencies. N, always good to know that N means the total number of people answering a question or taking a survey. You will be learning in labs how to group categories. This is very important. And paying attention to the direction of percentages and the calculation of them to see if it's an inverse or a, let's go with positive or a negative relationship. So a control variable is a third variable that shows whether a bivariate relationship holds up to alternative explanations. So this is where I got to be really clear. We're not doing it the full proper treatment in this running of the class because it's not that hard, but it's complicated enough that I thought when all this started happening that would lose it. Initially, we were going to tackle doing this in SPSS in a certain way, and but we decided to not because of what's happening. So what we're going to do is 2 bivariate tables, okay? And we're going to try and get the point across of doing a control variable and all that and keeping the main idea of it, but making it much simpler for you to deal with. Okay, so you'll be looking for 3 variables for assignment 3, and 2 of them are in the first cross tab, independent, dependent. And then the second cross tab, you'll keep the dependent variable the same, right? I just did that and I showed you guys that through GPA. GPA was the dependent variable and it stayed the same in both tables, but the independent variable changed. And that's because I wanted to see if something else was going on, right? The first one I was like, oh, okay, I don't know, looking at a relationship between private school or not. And then another one was about parents monitoring use of the internet. Now, we're not, so this is where I got to be a little careful. We're not doing a proper control kind of procedure here. And so that's okay. What we're going to say is it's fine if you just run 2 tables, and we're not going to worry too much about the the relationship between the 2 tables. Although technically to do a proper control procedure, you'd have to do that, right? You'd have to have good reasons for why, parents monitoring use of the internet would make sense as a control variable for the first one. All we're saying for this assignment and in this semester is just run 2 tables, keep the dependent variable the same, and just see if there's an effect or an association between those pairs. That's fine. We're just going to keep it really simple. So this is the elaboration model. Again, don't worry about it too much. Just I'm putting in like a couple slides. Maybe I think it might even be just this one, just to show that this is what we lost. And there's a bunch more of it in the textbook. It is very good for you to know that and to think about control variables. But again, we don't have an exam. So, what can I say? You're not going to have to memorize this or anything. We'll kind of just look at it and go, okay, if you are in a position of doing proper controls and stuff like that, you'd use the elaboration model. Yes, so in other runnings of the course, we have run through the full elaboration paradigm, and we've shown you how to do that in SPSS. We're not doing that this time. We're keeping things even more simple than usual, but it is good to at least know about a system created by Paul Lazarsfeld way back when. And I don't want to, it's tough. I want to just introduce it, but I don't want to get into it too much, again, because we're not going to be using it in assignment 3. You should at least know a little bit of the logic about it. So we'll use the some data from the Titanic. Perhaps you've heard of the Titanic or seen the movie. If you haven't, go check out the movie. Might as well when you're looking for stuff to watch. So it was obviously a pretty big event and very dramatic, but there's a lot more to the story that does get into in the movie, but some very sort of harsh things going on in terms of society at the time. So let's just look at a straightforward bivariate table here. This is independent variable, type of passenger. So we have crew member, female or child passenger, and male passenger. And the dependent variable is survivor. So survival, yes or no. And what you'll see is that many male passengers did not survive. The count there is 146 yes surviving versus 659 no, so quite a big difference. Female or child passengers, it's flipped around. Many more female or child passengers survived, 353 versus 158 for no. And then crew members, similar to male passenger, many crew members not surviving. So 212 survivors versus 673 non-surviving. So that's interesting. We look at that and go, well, that's it's terrible that it happened, but at least a lot of male passengers, it looks like, and crew sacrificed themselves to save the women and children. But here, the story changes somewhat as we add a third variable. And the third variable is class. So class in terms of the kind of ticket, first class, second class, or third class. And so what's interesting here is that when we introduce that variable and then we look at a breakdown, we will see that this other variable was actually having a really profound impact on the dependent variable. And this is very interesting as well. And what we see is that generally across the board, people in lower classes did not survive as much. So third class passengers, 528 did not survive versus 178 that did. As opposed to, say, first class, where the numbers of survivors is 203 versus 122. So very interesting pattern emerges. It's not just about male passengers sacrificing themselves or crew, but the fact is that if you were in a higher class and you had a higher class ticket, a more expensive ticket, you were much more likely to survive. Here's another example. This is about male versus female drivers and the rates of accidents that they incur. And so this is, I believe it's data taken from, let me just see here. Oh, sorry, there we go. Hans Zeisel, say it with figures, and just trying to make an important point here that when they collected this data and they just broke it down by gender, so women had a 68% accident-free rate versus men at 56%. So this suggests that females are safer drivers, basically. When we look at this, there's a bigger than 10% difference. And what we're seeing is that women drivers are having less accidents, basically, by looking at this. And so that may be true anyway, but the interesting thing is to introduce a third variable. And in this book and in this data set, they then looked at distance driven in a year and looked at people driving less than 10,000 kilometers versus people driving 10,000 kilometers or more. And then they found that actually the difference went away. And this control variable takes into account the fact that in this data set, women were driving less, and because they drove less, they had less accidents. And so this is suggesting that it's not necessarily true with this data set that women were being safer drivers or better drivers. It's just the fact that if you took distance into account, then the initial difference of over 12%, around 12%, kind of goes away, and basically we're held with numbers that are very similar for men and women. Okay, so good news for you guys, though, is that we're not doing all that kind of stuff. It's just too much for us, and I think we struggle with a bit it a bit anyways under normal circumstances. But right now, given what's happening, we wanted to make it a lot simpler for you. So this is all good news, I think. I mean, the third assignment has been weighted heavier. That's true. But the expectations for it have been reduced a bit and switched around to accommodate things. So all in all, it should be a good case scenario for you. And yeah, this is the first time we're doing this. I hope it is going to work out for us. We will be experimenting with different ways of delivering our course online a little bit, but it's going to be fine and everything's going to be fine. So just relax and work on your assignment.